All right, welcome back. On this video, our plan is to show how we can use the area models to do a process called completing the square. It's the kind of thing that we want to do if we want to get a quadratic that is in its standard form into the vertex form. So we'll start out with this one right here, f of x equals x squared plus 5x minus 13. The secret of this process is that we are completing a square, and this is very much visually completing a square. So we're going to start out here using the same kind of thing that we use for factoring and multiplying polynomials, but with those we use specifically a rectangle. Here we need to very much make this thing a square. And so if this is going to be a square, and the key characteristic being that side lengths are equal, then we know that the x squared is going to fall in that upper left-hand corner, which is going to make this x and x. We know that the two boxes on the diagonal this way have to add up to 5x. That's no different than what we were doing when we were factoring, but now, since this is going to be a square, that 5x has to be split equally between those two parts. So 5/2 of the x needs to go here, and 5/2 of the x needs to go there. So half of that 5x goes in each of those boxes. But once we've locked that in, then if this is x wide and the area is 5/2, then this means this has to be 5/2, and this also has to be 5/2. But if those are both 5/2, then we know the area of this square down here, which is something we don't yet have, so we are going to complete this square by filling this box in with a 5/2 times 5/2, which is 25/4, which is great. We've completed the square, but the problem is, where did that 25/4 come from? I just threw that in there out of the middle of nowhere, and so the notation we're going to use here is we're going to have this red circle, which is going to contain nothing. Okay? Right now it contains 25/4. In order for it to contain nothing, I'm going to have to subtract 25/4 as well. Okay, so now the thing that I added in, I've also taken away, so I haven't actually changed the problem. And what I haven't dealt with in the problem yet at all is this minus 13 that was hanging out there. So I'm going to get that minus 13 out here as well. Okay. Now, everything that is on here, if I take the area of everything that is in this square and add on these other two things that are out there, then what I have is x squared plus 5x minus 13. So this is my equation in a symbolic form here, or a little bit more visual representation. So now I'm going to rewrite this thing in terms of the square. This square has side length of x plus 5/2. And since it's that same on both sides, since the area of a square is s squared, then that is x plus 5/2 squared. And then to that, I'm going to add on this part that's out here, this negative 25/4 minus 13. So minus 13, of course, is minus 52/4. So I have negative 52/4 minus 25/4 is negative 77/4. And this is now my function in its vertex form. Vertex located at negative 5/2, comma, negative 77/4. All right? Okay, let's do another example. Let me scroll down here and find another one. So in this one, we've got a little bit more going on here. We're going to complete the square. The directions are exactly the same. We're trying to accomplish the same thing. But now with this negative 3x squared out in front, that's a little bit, if I tried to make that square and say this was going to be a negative 3x squared, then figuring out what was going to be on these sides, what do I multiply together or what do I multiply by itself to get negative 3x squared? Well, the x and the x are fine, but multiplying things together to get negative 3, that doesn't work very well. Okay. So I need to make a modification first. And what I'm going to do here is take a look at these first two pieces that are here, and I'm going to factor a negative 3 out. So I'm going to write this as negative 3 times x squared plus 8x, and then I've got this plus 7 hanging out on the end, and this is what I am going to model. I'm going to complete the square on this part alone, so I will build my square, and now the x squared goes in here. That's easy. There's my x and x. These two things have to add up to 8x. Since it's a square, I have to have equal parts in there, which now means I know this has to be a plus 4, and that has to be a plus 4, which means that has to be plus 16, which I threw in there out of the middle of nowhere, and I can't do because that would change the problem, so I'm also going to subtract 16. So that is what is under the red underline. I've got an x squared right here, and I've got the 4x plus 4x gives me the plus 8x, and 16 minus 16 is 0, so that's exactly what I have inside those parentheses. Now, if I'm going to model the rest of what I have, I've got a big set of parentheses around there with a negative 3 in front, and a plus 7 on the outside here. Okay, so this is a great big visual representation of what's going on, but I can do the same thing. I'll keep my negative 3 and the set of parentheses, but now my red box in here I'm going to write as an x plus 4 on each side, so that red box is x plus 4 squared. There is a minus 16 that is still there inside these blue parentheses, and a plus 7 on the outside. And now I'm just going to distribute. Okay, I'll distribute the negative 3 in here. That gives me a negative 3 times x plus 4 squared. Negative 3 times negative 16 is a plus 48. And then I've got the plus 7 on the outside, so the vertex form of my function is negative 3 times x plus 4 squared plus 55. We've got a vertex here at negative 4 comma 55. It opens down, and it's kind of skinny in there. We could do that analysis with an arrow diagram of exactly what the transformations are that are being done if we were interested in doing that part of it. Okay? But there are a couple examples of how to complete the square with a very visual representation of why it is called completing the square. Okay, I hope that helps out with all of those problems.